Hello everyone, this is Bradley. Today this is a fundamental tutorial talking about some issues of motion blur in geometry nodes, which we may solve or not using set ID. And this is a pretty extensive topic, and I'm not sure if I'm going to split that into two different parts. It depends on the length of this tutorial, but let's start. So here we're in Blender. And I want to firstly start with a very extreme case where we do not expect motion blur to work, and it's not supposed to work regardless. So in this case, we're trying to switch between a cube and a UV sphere. This is a very extreme case, and it's probably not practical because in reality, it's very rare to see that we are trying to switch a cube and we are animating this switch with a keyframe and so on. Okay. It does not happen. It's more likely in reality we're trying to set a position and we try to sample the index of a position, trying to morph the cube into another form. Okay, so the cube is still a cube so that the motion blur can work. But in this kind of case where you just switch geometry, it will not work for motion blur. This is simply because the motion blur cannot really understand how a cube becomes a sphere. It does not know how vertices is moving to create such kind of motion blur. Similar kinds of issues also apply to cases where you are trying to animate or keyframe the subdivision level, or there's a decimate modifier to unsubdivide a geometry, and you can definitely animate the ratio. It's probably not common that you animate these ratios, but I want you to understand that if your changes of geometry is somehow very disruptive, where it fundamentally changes the look of your geometry from one geometry to something totally different, then the motion blur will never work in such kind of case. Next, we are going to discuss some cases where you expect it to work, but somehow it does not work or does not work correctly, and some possible solutions, and so on. Okay, so let's go to another example. I'm not going to really explain this setup because it's really for demonstration purposes. I don't think I can come up with an easier demonstration, but I just want you to understand that this is what we're happening here. That I'm moving these spheres to the right. This is kind of very simple, okay? And if you render this image, then you can actually find the trace of motion blur. It's not very obvious, so let's turn on the shutter a lot so that we will have very blurry image. It looks kind of very ugly, but you can make it better by tweaking different settings. Here, this is just for demonstration purposes. I want you to understand that since these instances are moving to the right, so they're generating this kind of motion blur onto the right. Okay. The problem often occurs when you're trying to disrupt the geometry, just like what we show. But at some point, you may still expect certain things to work. So here, right now at the end of this node tree, we're trying to output in these instances. Okay. So this is the final output to our geometry. And now if you delete the point where you generated these instances and you play this animation, you can see this is what's actually going on. You are deleting these points or instances while you are moving. And now if you try to render the image, you will find there is something wrong with our motion blur. Previously it was going at a horizontal direction to the right, but now this is going upper right direction. This is because that these instances are using an ID attribute to map its location. And by default, this kind of ID attribute is using the index. So at some point, they are actually identical if you do not set that explicitly. So what it happens is that the first index was original there, but because it's deleted, so it moves to the other direction. And as you are deleting more points, it keeps going into a different direction. So that's why you're seeing this right upper direction of movement and the motion blur. But this is obviously wrong. So we want to keep the mapping of ID to its original location. So this is not the first point, but this should be maybe about 5th point for this array. Okay. To solve this problem, we basically do something we commonly do as we call that the capture attribute or store named attribute. In this case, we're trying to do that with ID. And there is already a very specific node doing such kind of function, which is called set ID. And you need to put that before this delete geometry so that the ID mapping will be captured or stored at the moment before everything is being deleted and remapped. So in such kind of case, you try to render this image again. You can see this motion blur is working correctly at the horizontal direction. It's very ugly, but as we said, you can always tweak the settings to make it look better. Okay. So this is kind of case where you can solve the disrupted motion blur because of this delete geometry. I also want to remind you, this is not just about the delete geometry, but sometimes for all such kind of cases where you separate the geometry or other things that you modify the points somehow. Okay. Any disruptive case misleading the motion blur will cause problem and can be solved with this set ID. However, there are some additional conditions that will again disrupt motion blur. That is realize instance. So right now we disable or this kind of delete geometry and set ID. Let's enable this realize instance and hit render image. You will find that this motion blur is working correctly. However, if you enable this delete geometry, you will find motion blur is completely lost from the setup. Okay, so if you combine delete geometry and realize instance, you will not have any motion blur. And this is a limitation that you cannot really solve. So even if you set ID before, you will not solve it. And even if you delete geometry after or set ID after, you will not solve it as well. Okay, so this is very unfortunate, but there's basically no way to solve this issue of delete geometry and realize instance all together. So in a case where you want to keep the motion blur, but also variances of instances, it's very recommended that you do not realize instance. So if we do not realize instance, how can we create a variation? I've already made a tutorial talking about how to create variations using repeat zones and pick instances and so on. I'm not going to repeat in this particular tutorial. Rather, I'm going to talk about something else about particle system without realized instance. This is because the moment we want to delete the geometry and realize instance or create variations are frequently for particle system as well. That's also a very big motivation why I'm talking about it today, because it can be used after. Okay. Before we move on for such kind of topic, I also want to remind you that currently Eevee cannot do this, but if you try to render these particles, you see that it does not appear in the scene. Okay, but Cycle can actually render these point clouds in render view, and somehow it works just like realized instances. So you try to render the image, you get very weird cases, and oh, it does not really work even with realized, even with set ID. Okay. I don't know. So this is pretty bad, which is also very unfortunate. I don't know if you have ways to solve it now or not. But currently this is the status, which is very unfortunate. So sometimes perhaps a little bit of instance is not really bad, because at least you get kind of a correct result if you get a set ID. Okay, we are going to discuss this further. Talking about variances in particles, it's more usually for color changes. Okay, so for example, sometimes we want to have random color, and as you may already realize that we are having an emissive shaders on our instances. And how can we get different colors? If you use object info nodes, then it will output a random value for every instances. As you may see, some of them is white, some of them is gray. This value goes between 0 to 1. If you want to give some more specific kinds of color, then you can try to use color ramp. So some of them is red, some of them is blue. Then you get this kind of variances. If you want to change the seed, then you just use white noise texture, and you can combine X, Y, Z, and you can change the seed of it. Okay, this is kind of very easy and simple, but this random number generation is not up to your control. So sometimes you may want to store a named attribute to output some geometry node information to shader for it to use. Here I want to remind you that it usually does not really matter if you store named attributes before or after this instance on point. It's just that since the geometry domain is changed, you want to change the domain accordingly. So here for convenience, I'm going to just store named attributes at the point before the instance on point. And let's just take an index, just as an example. In reality, this can be any other attribute. Maybe it can be the age of our particles or some other ID of our particles. And here, let's just name that as an A. The name does not really matter. You just need to make sure that the attribute node is calling this name correctly. That's why I sometimes just use one letter to replace the stuff. Otherwise, it will be so complicated. And now if we visualize this factor into these outputs, you will find there's no color. It means the value is 0 throughout. Okay. The reason it does not work as expected, this is because we are not working with geometry, but we are working with instancer. Okay. So now once we change that to instancer, you can visualize all this kind of index, which is going from 0, 1, 2, 3, 4. But you also realize there is a problem that previously I mentioned that it does not really matter if you store named attribute before and after, but only because that we are actually deleting the geometry, so that the index is always being shifted. So the black always goes to the other direction. This is why motion blur was disrupted without this set ID, and this is also why we need to set ID before this delete geometry. So in this case, to solve this kind of problem, you probably want to store this named attribute before this delete geometry, so that you can see the color is staying consistent. You can basically do the same for random color generations, and in this case you can see the color does not really change. However, if you store these attributes after, you can see this color basically shortens to that direction. Okay, so this difference is only important if you are trying to delete the geometry and so on. Okay. This tutorial may be kind of long already, but unfortunately, this story didn't end before. As I mentioned, the major practical example related with this delete geometry and instances is for particles. And obviously, we do not work with just a fixed amount of particles. We sometimes want to do simulation with more particles with it. I'm not going to explain this simulation zone setup because it's too time consuming, but I want you to understand its behavior, which is basically just moving points upwards. And if we directly take a render, you can see the motion blur is working as expected. And if we delete these geometries, then we render again, you can see we have a disruption of motion blur for the reason we mentioned before. And if I start to set ID and render image again, then everything recovers. Okay, so this is kind of okay, but you also need to realize that this example is actually not really practical, because we're simulating particles generations. It's very likely that you are always containing billions of particles in your simulation zone, and you may want to actually delete these particles, whether it's on collision or simply because they are too old. Okay, so instead of deleting these particles outside the simulation zone, you want to delete these particles inside the zone to reduce the total amount of particles being simulated, so that you can save some performance of your machine, so that you can hold more particles at a time. Okay, so in that case, we need to delete geometries inside the simulation zone. And let's start with a setup and see the results. Yes, it's working. It's deleting these points. So now if we render this image, we can see this disruption of motion blur. And if we start to set ID and we play this animation again, and we render this image again, you still find there is a disruption of motion blur. But didn't we actually already set ID before the deletion of geometry? Why this problem occurs again? This is because we are running a simulation zone where you start with simulation inputs, you run this loop over time. It means you run this process at the until the end of a simulation output, and then you go back the simulation input and run this process again. This actually means that you set ID in your current frame, but you keep resetting this ID in the next frame as well. So you keep rewriting this set ID, and this set ID is actually using the index by default. Okay, so this comes to the same problem as the issue we saw that earlier, that we delete this geometry. So the first point becomes this one, and next frame, the first frame becomes this one, and the next few frames, the first point becomes this one. So this set ID is always changing its mapping within this point cloud. Okay, that's why it's not working. So we need to set an ID and make it more stable. This is a moment where we need to set this ID before everything is being joined. Okay, and now if we play this animation with render image, you can see it's working. However, this is not correct still. Right now we are only emitting a single generation of particles. But if we're emitting multiple generation of particles, so let's go with another example. This example is a little bit more complicated because we're increasing more generations of particle emissions. So now you can actually see that we're emitting particles, but they are going straight to a different direction. Okay, so now if we let's firstly disable the delete geometry. So we have many particles, and I render image. You can see this motion blur is always going a straight direction because the particle is only moving straight outwards. Okay, and now let's enable this delete geometry. It's deleting a very fast speed. And now if we enable this motion blur, you can find that there's something wrong with the motion blur. It may not be very clear on this image. I'm not sure how to make it more obvious in this case. Maybe reduce the shutter. Hopefully it will work. And you can find that this motion blur, sometimes this motion blur is going in a very weird way. And yeah, it's kind of very weird. It's almost kind of chaotic. Even if you try to render a different image, you can see it's just being crumbling somewhere. Yet it's not a very very clear as before. But the question is why, even if we set ID. This is because that we are setting the same ID for every generations. So for the current frame, we are setting the ID in a way of 0, 1, 2, 3. But for the second generation, we are still setting the ID of 0, 1, 2, 3. So there is actually a lot of 0, 1, 2, 3 particle in the scene. And the motion blur still gets confused that there are multiple particles whose ID is 0, 1, 2, 3. Then who is whom? How should I map the motion blur? Okay. So in this case, we should actually make ID much more different from each other instead of using the index by default. Okay. Then we come to a very interesting question about this set ID node. I believe many people haven't really used this node because its existence is quite weird and there are lots of pitfalls related with it. So ID attribute, it does not exist by itself, even if you commonly see it in nodes such as random value node. But if you actually visualize this socket, it will say this integer field is actually based on ID or index. Okay, and if you try to visualize this ID, you can see this ID is actually in order of 0, 1, 2, 3, 4. So this ID is by default actually using the index value. This is the same when you are trying to set ID. Okay. There is only one exception currently in geometrynodes that's actually creating this ID attribute, which is point distribute, or distribute points on face or volume or other things. So now we do not mesh to points, but we are generating these points. You will see that there's an ID being generated. I do not know how many digits it actually contains, but it's an integer number. Okay, and once we have this ID, this correct ID, we do not need this set ID, and we are going to take a time frame so that every time you generate different seeds, different ID. And now if we try to render this animation, then you can find this motion blur gets as correct as before, that everything is just pointing outwards instead of having a very crumble and noisy whatever images. Okay, this correct mapping is because we are having a correct ID as we are generating these particles. Okay. Here I want to remind you that sometimes when you are working with ID, you may be satisfied with the index default in this set ID, but it's usually not really that recommended, because ID is supposed to be very unique. The problem is not very obvious in cases like random value node, because we have an additional seed that's also easily creating the variances in addition to this ID. But you need to understand ID is also a part of the seed. Okay, and if we only have ID as a seed, then obviously just adding this index number with any other value, such as a frame number, is not sufficient enough to create a very nice seed, because you're just making the sequence to be a little bit shifted, but eventually you are still having the same seed. Okay. So here we are going to talk about a very good way to actually generate very unique ID in geometry nodes if you are not using this distributed sound phase. And basically that way is the white noise texture node we have previously. And you can see this is a 3D noise, and it contains a vector input where you can actually combine XYZ. Actually, this will be the base for many other nodes and the system in geometry nodes, such as what you see from the random value. And in the future, there will be a hash value node, hopefully in 4.2, that's do similar kind of work. Okay, but I think this way is actually better because you have more control. The downside of white noise texture node is that all values is decimals. So what we need to do is to multiply with a very large number. And the benefit I'm mentioning is actually you can control the power of magnitude you have. So the base is 10. Let's set this exponent into some other integers so that we can multiply with this value as a magnitude we want. And then we can float to integer to round that up to a final integer. So now we have the basic system, and next we basically just combine different value. As you can see, we have the index, and we also have a frame number, so that every frame we're generating a different numbers. And as you can see, that we have this first number as 39, but then it can become 37, 22, 95, 75, 76. The number can be very different, and especially more different as you are increasing the magnitude, then everything becomes very unique. You can also add up a system where you can generate negative numbers. For example, maybe this number is greater than 1000 or 5000, then you switch a positive value and a negative value and so on and so forth. So there are many different ways to do, but at some point I think with this different magnitude is already good enough to generate unique IDs. Okay. So now let's try to preview the effect of this ID. Let's play this animation, and as we see, this particle is being emitted and deleted. Let's hit the render, and we can see that this motion blur is going outwards as it should. It seems to work perfectly. If there is any issue, then just try to increase the magnitude or even change the seeds on the z-axis, or implement additional algorithm to give a negative value. The whole point is that you want your instance to have a very distinctive ID from point to point, so that they must not collide with each other and confuse each other. Okay. At the end, I want to talk about some caveats or pitfalls related with this ID attribute. One thing you may already realize that despite the fact that we are having this ID node in uppercase, but the actual named attribute is lowercase. Okay, this is the same if you are trying to use the named attribute form, which is lower ID. These two are basically 100% the same. The only difference is that this is more convenient to call instead of that you have to search for values. But you need to understand that this difference between uppercase and lowercase, because if you're trying to use this value in shader, just like what we did earlier, that you must use lowercase for ID so that you can generate a different colors consistent. Okay. Another important thing is that this ID attribute is trying to make sure everything is completely unique. And it will actually cause a problem that currently our first point is 661671. Okay. And this is the same for this entire instance of a sphere. But if you try to realize instance, and if you look at the vertices, you will find that these IDs are not the same as the instance, and they are not really overlapping to each other. This is a feature that this realized instance will actually break down these IDs. Okay, so it's not really the same as what you usually do with store named attribute, that this attribute will be propagated to the instance without any fundamental changes. So if you want to have a stable ID, you would better to store a named ID instead of a set ID. This is a caveat. But in this particular tutorial, since we're talking about motion blur and we want instance outputs without realized instance, so you probably do not worry about it. But you need to think about it when you're working with realized instance. Actually, this kind of disruptive feature of realized instance may also be actually the reason why motion blur does not work when you both delete geometry and realize instance. Anyway, so at the end, there's another caveat of this ID. Previously, I mentioned that you can increase this magnitude, but increasing this magnitude finally ends up with an actual limit. So let's go to our last example, and we do not need all this kind of stuff. I do not need the index, I just need this ID generator. Okay. So we only have this ID generator, and I'm using a frame number to change the change of white noise and ID. And we take a point, and let's go with a random value. We go with a random vector and plug this integer into ID so that we're basically having a seed for this random vector to move our points. And you can see this point is in the space. And as we are using time to drive this white noise, we're expected to see the changes of this random vector generation over time. But there is a limit. If I change that to something like 10 to the power of 9th, then you can still see there's changes of values. But if you go to 10 to the power of 10, you can see it barely moves. And it basically stops all the movement if you go to 10 to the power of 11th. It actually means this ID contains a limit about positive or negative 10 to the 10 to 11th. Okay. So over this limit, no random number will be generated with this kind of ID. This is the same as we're doing white noise texture, because the core functionality is basically the same with this white noise texture as what we are doing here. So if you plug this ID into a white noise texture and you use the color to drive the position, you basically see it's not moving. But once you're going below this limit, like 10 to the power of 9th, it will work perfectly fine. Okay. This is the same if you're trying to with Voronoi texture or other things. I haven't really tested all textures, but there is one exception of this limit, which is noise texture. This noise texture has a much lower threshold of this random number generator. So we try to decrease this value to 10 to the power of 6. You can see it's moving, but somehow it's still kind of weird. And about 10 to the 7th, it's basically even worse. And the 10 to the 8th, it stops the movement. So basically, the safe range is about 10 to the 6th, something like that. So basically, the noise texture has a much lower limit that you go 10 to the power of 7 to 8. Okay, something like that. So if you are trying to make this into a random number generator, for example, if we can plug a object info and we have a self object node, you can plug this location into the white noise and generate a random number, so that for each instance of your geometry node tree, you can have a distinctive random number for every object as you're duplicating them and so on. You need to potentially worry about this limit if depending on the actual texture you're using in the node tree. So in this case, I would recommend to keep your limits like 10 to the power of a fifth, which is very safe below this kind of weird limits and so on. Okay. So this is just a warning, but at the end, it's up to your choice and so on. That's why I think making this into a group node is better than providing a direct node of hash value, because you can actually control the actual integers or magnitudes of power you have for your final seed. But anyway, so I hope you enjoyed this video. I'll probably see you next time. Bye bye.